Hi, I'm Obi Mosu, and this is Lab 3, Circuits and Capacitors. So in this lab, we will be using the principles of energy and current conservation to predict and examine the behavior of currents in series, parallels, resistors, and capacitors. We will also use multimeters to measure values to determine the time constant of an RC circuit. And these are some of the relevant formula we've used. So just some of the brief previews of results. We can see everything on this slide here. And one thing that's really important is that V always sums to 0 across a complete circuit. We're going to use that for our calculations. And also increasing resistance in the RC circuit increases the charging and discharging time of the capacitor. So these are just some of the experiment backgrounds. Initial conditions, that circuit has some initial charge and current flowing through due to the battery. So yeah, these are just some circuit backgrounds. And these were our results. So we made the prediction that the total resistance is 147 ohms, total voltage is -3. And we use all this to calculate the current of 0.0204 amperes. No change when we reverse the connection. When we replace the ammeter with a voltmeter, ammeter reads 0A because voltmeter has very high resistance, and voltmeter reads 3 volts since there is no other voltage drop. So ammeter readings do not change due to low resistance in the ammeter, so current is not affected as it flows through, but voltmeter has a very high resistance, which does alter the current. And yeah, the graph shows increased resistance impacting current. Current rises abruptly as it gains charge from the batteries, but decreases due to resistors. And these are some of the assumptions that we had to make. No charge could be lost to the surroundings, and also errors in the experiment, likely due to decreasing battery charge over time, faulty components, etc., which we'll get into a little bit later. Yeah, this is just another slide of the results. And yes, this is also more results. And these are the diagrams that we used. And these are just some what if questions. So what if you charge a capacitor with no resistor in the circuit? Basically, in this ideal model, the capacitor would charge way faster than observed in the experiment because the current would flow directly into the capacitor without being impeded by a resistor. But this is very unlikely or impossible as all batteries have some type of resistance slowing charging time. A resistor may still be necessary to prevent electrical damages. Measured time was larger than predicted and took several seconds. This is likely due to the natural resistance of the components mentioned above. And these are just some potential error sources. Battery charges. Obviously, I was not the first person in the lab to use those batteries as they've been used throughout the day. Old components, basically the same idea. Burned light bulbs. Not all light bulbs are going to be the same after they've been used, or just inaccurate multimeter. It could just be faulty or inaccurate due to battery. But yeah, that's all. Thank you for watching.